Okay, in objective 2 in this lesson, we're going to be able to find the area of a triangle graphed in the coordinate plane using determinants. So we know how to find the determinant of a 2 by 2 and a 3 by 3 matrix. It's going to help us find the area of a graphed triangle very, very easily. Okay, so find the area of a triangle in the coordinate plane like you see in this diagram right here, where you have some generic coordinates, x1, y1, x2, y2, x3, y3. So 3 points, the vertices. Okay, it's as easy as taking half of the determinant of an augmented matrix. The word augment means just to add a row or a column. Specifically, specifically, we're going to add a column. And we're going to add a column of ones, as you'll see right here. So here is then the area of that triangle using a determinant. Okay, so the area is equal to plus or minus 1/2, and then you find the determinant of, look across the top row. It's just the first coordinate, and then you put 1 after it. Okay, the second row is the second coordinate, and you put 1 after it. And the third row is you put the third point, and put a 1 after it. So we've augmented it with a column of ones. Alright, so you might be going, well, why is it plus or minus? Well, let's say you find the determinant of this matrix and it's a positive number. Okay, so I take half of that, it's still a positive number. I want to keep the positive answer because the area of a triangle is going to be positive. But let's say we take the area of, or we find the determinant and it's a negative number. If it's a negative number, then I'm going to multiply it times -1/2 to make it positive again. Okay, so that's why the plus or minus is out there. Alright, now, so for the extra credit for this 6 weeks is to prove this. Okay, it's worth 5 points on the whole 6 weeks average. Okay, if you look under the extra credit section of my website, it'll give you a little bit more details on what you would have to do in order to prove that thing. Okay, alright, so in the meantime, we're just going to use it. So let's find the area of the triangle. This is what we started the whole entire lesson with. Let's find the area of the triangle using the determinant there. Okay, so we want to write ourselves, we want to write ourselves a determinant, so the area is going to be equal to plus or minus 1/2 of, just take these point at a time, it doesn't matter what order these points come in, so let's just go with a 4, a 2, and a 1. Remember, I always put a 1 at the end. Okay, so there's B. Let's go with C here, 3, -4, and then put a 1. And then last one, oh, I did this one. Last one is a 1, a 2, a 1, and -2, and a 1. Okay, so now whenever I find the determinant, I can either use expansion by minors or I can use the diagonal method. It is completely up to you. Let's go ahead and use expansion by minors, right? Because it's everybody's favorite. So the area is going to be plus or minus 1/2 of, put a big old bracket around here. I'm going to pull out the 4 first, and then find the determinant of, well, I don't even have to write what the determinant is. I can just write the numbers here. So I cross out the column in the row that it's part of. The -4 times 1 is -4. -2 times 1 is, it's minus a -2, so plus 2. Okay. It's positive, then it's a minus, pull out a 2 from that second element, and then cross out the row in the column. It's going to be 3 times 1 minus 1 times 1 is 1. Plus, now pull out the number 1 here, cross out the row in the column. 3 times -2 is a -6, minus 1 times -4 is a -4. Okay. Clean it up. So I've got plus or minus 1/2 still. Brackets here, this is a -2 times 4 is a -8. And this one is a 2 times -2 is a -4. And this chink chink is a -2. That's a -2. Is equal to plus or minus 1/2 of. Chink, chink. Inside here, that's a -12 minus 2 is a -14. Now here's where the plus or minus comes in handy. If I multiply it times a positive 1/2, I get a negative number. So I'm going to multiply it times a negative 1/2, and I'm going to see that the area here is 7 units squared. So I think that would be a lot easier than having to say find the length of BC and find the length of the height to that thing and multiplying it by half. But it may not be as easy as, say, finding the area of a whole entire rectangle and subtracting it off. As a matter of fact, it's the same thing as that. That's exactly how you prove it. There's a hint on your extra credit. Okay? Okay, so why don't you give it a try on this next one. Find the area of the triangle whose vertices are at 511, 92, and 13. Yeah, sorry you don't have a picture on this one, but I think you can deal without it. So put all that in a 3x3 matrix augmented with 1s. Find the area of that triangle. Pause it, give it a try, come back. Let's see if you did it right. Okay, so this is what you should have gotten. So I'm going to make the 3x3 matrix with the first point, 5, 11, put a 1 at the end. And the second point, 9, 2, put a 1 at the end, and then 1, 3 with the 1 at the end. I did expansion by minors. Seems to be my favorite method. Anyway, so do all the math, simplify all the numbers. I get an area of 34 units squared.